So on percent error questions, the student finds the density to be 10.2. The correct value is that. So I have an experimental and an accepted value. So percent error equals accepted minus experimental over accepted times 100%. Okay. So just putting the buttons in my putting the numbers in the right place. The accepted value we said was 10.6 grams per milliliter. The experimental was 10.2 grams per milliliter. And the accepted again was 10.6 grams per milliliter times 100% equals. Now, if you just push these buttons on your calculator, you're going to get a bizarre answer. So 10.6 minus 10.2 divided by 10.6 times 100 equals. And my calculator says negative 85.6. Was I off by negative 85%? No way. I wasn't 85%. Well, those are pretty close together. What did I do wrong? What I did wrong was that. Okay? That implies that I've got to do the subtraction first, get that answer, because that's inside parentheses, then do the division and multiplication. And notice that I've got two sets of sig fig rules. I've got subtraction, where it's decimal places, and division and multiplication, where it's sig figs. So between those two, I've got to stop and round. So 10.6 minus 10.2 is 0.4 grams per milliliter. And I still got the 10.6 grams per milliliter on the bottom. Hey, grams per milliliter cancels out. That's good. Times 100%. And 0.4 divided by 10.6. Well, 0.4 has 1 sig fig, 10.6 has 3. This can only have 1 sig fig, so I got 4%. Notice how percent is a unit. And we can treat it just like a unit. Oops, did I get it backwards? Experimental about accepted. You know, I fight this one every time. Okay, so it should be experimental because your book gives it a direction. Most places put absolute value bars here. So I always forget which way. And the way I remember which way it is that if the experimental is too big, it should be positive. So I should have had those two reversed, which gets me negative 0.4, which gives me negative 4%, which tells me my answer was too low. So the negative tells me my answer is too low, and I'm low by 4%. That sounds a lot better than the negative 85.6% I got when I just pushed buttons on my calculator. So those where I saw some mistakes. People not stopping and rounding and doing sig figs here. People getting the volume one upside down. And again, subtracting to lose sig figs on the density problems. Does anybody have any questions about the either density or percent error that I can help? Does those make sense? I haven't graded them yet. I looked at a few, but I didn't grade them. So if you've made those mistakes, take the time to go back and look at them tonight. All right, so today, our topic of conversation is conversion factors. Okay, conversion factors. When we started this year, I said we were going to learn a powerful mathematical technique. Okay, powerful mathematical technique, and this is that powerful mathematical technique. Okay, it's not hard. It's really easy, but you got to do it in an organized way. So here's what a conversion factor is. A conversion factor is a ratio of equivalent measurements. Okay. So equivalent measurements. Can anybody, you probably think of what an equivalent measurements that are equal to each other. Well, we talked about a whole bunch of them last time we were together. 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. Equal measurements. So I have to start off with two things that are equal to each other. Like 1 meter is 100 centimeters. So that's the equivalent measurements. Some places call this the equivalent statement. Equals statement. What's equal to each other? And you can look those up. You can find those out. Doesn't matter actually where you get them as long as you know two things are equal to each other. And now, so we've got the equivalent measurements part. Now we need to do the ratio. And ratio means something over something. Right, I got to have a top and a bottom. And that implies division. So what we're going to divide by each side to come up with two ways of writing the number 1. So we've got two ways to write the number 1. It sounds complicated and nasty. It's really the most simple algebra. Okay? It's really just basic algebra. So there's my equivalent statement. We said we're going to divide. So I can divide. Well, it does. I'm going to follow algebra. I'm going to divide both sides by 100 centimeters. Algebra says you can do that. And if I do that, my right-hand side, the 100 centimeters cancel out, and that leaves me with 1. So divide both sides by the 100 centimeters, and I get 1. So it's 1 on this side, and this is a ratio, thing on top and thing on the bottom, of equivalent measurements. This is the conversion factor. This is what we're trying to make. But we said we could do 2 of those. So last time I divided by the 100 centimeters. This time I'm going to divide by the 1 meter. Now on the left-hand side, the 1 meters cancel out. And I'm left with 1. And this is the second conversion factor. So, every time I start off with an equivalent statement, I can make 2 conversion factors. One with 1 on top, one with that same thing on the bottom. Okay? That's all there is to it. So, let's try a few. Actually, not try a few. Okay, so you can see that all we did was write 1 in a bizarre way. Now we're going to multiply and divide by those ratios, so we have to think about sig figs. Remember, sig figs come from measurements. Okay? But do you have to measure 1 meter to find out it's 100 centimeters? Did scientists have to measure it? No. They just defined it. So there is never going to be 101 centimeters in a meter. There's never going to be 99 centimeters in a meter. They're exactly 100. That means 100.00000 and zeros on forever. And since I put that 0.000, all those zeros would count. So that 100 has unlimited significant figures. It's not going to change the sig figs. And equivalent statements are going to have the relationship that we got used to earlier. That is, the big number is going to go next to the small unit, and the small number is going to go next to the big unit. If the number gets smaller, the unit gets bigger. Although most often we go, my unit is getting bigger, so my number has to get smaller. It takes a lot of little pieces to equal a few big pieces. So millimeters. Millimeters are small, meters are big. Millimeters are smaller than meters, so my unit is getting bigger, so my number has to get smaller. And vice versa. If I went the other way, my number is getting smaller, so my unit had to get bigger. So always make sure you have the small number with the big unit. That's the most common mistake. And the places where it's a mistake is 1 kilometer is 1,000 meters. Many of you are going to write that 1,000 kilometers is a meter. Now, 1,000 kilometers is about 600 miles. Does 600 miles equal a meter? Nah. So not the same. So how did we get those conversion factors? We took our equivalent statement and we just divided by both sides. So let's do the conversion factor between kilograms and grams. I have to start off with kilograms equals grams. Which is bigger? The bigger one is the kilogram. So the kilogram gets the 1. The gram gets the number that makes it true, which is 1,000. There are 1,000 grams in a kilogram. Now, I need to divide. So I can divide both sides by 1,000. And I get that 1 kilogram over 1,000 grams is 1. That's a conversion factor. Now, do we have to go through the division all the time? Nah. I know where I'm going to end up. Okay, so this one had kilogram on top, so I need a second one that has kilograms on the bottom, divided by kilograms. I'll be able to put grams on top. And the kilogram is bigger, so it gets the 1. The gram is smaller, so it gets the big number, which is 1,000. And those are our two conversion factors for grams and kilograms. So we should just figure out what goes on, put one on the bottom, then put the other one on the bottom. Or put one on the bottom, then put it on the top on the second one. So what about feet and inches? In the middle of the test, you chat to me and say, Mr. Green, I don't know the relationship between feet and inches. You know what I'll say to you? I'll say to you, there are 12 inches in a foot. Because I don't care if you know the English system for my class. But if you ask me how many grams are in a kilogram, I won't tell you that. I need you to know the metric system. the English system, I will always give you the tools you need to get from point A to point B. So 12 inches is 1 foot. So we can write 2 conversion factors. Okay, so my 2 conversion factors. And here's how I make my choice. Inches is either on the bottom or it's on the top. If inches is on the bottom, then feet has to be on the top. If inches is on the top, then feet has to be on the bottom. Now I just have to make them equal. Well, 1 foot is 12 inches. Here's a silly mistake people make all the time. 12 feet equals 1 inch. Is that true? See, if you say it out loud, it just hurts to say 12 feet equals 1 inch. No, that's not true. 1 foot is 12 inches. Thing on top and thing on the bottom have to be the same size. So it works if they're all metric. It works if they're all English. If there's one metric and one English, it works because they tell you what's equal. And I would have to give you this. I don't expect you to know English and metric conversions. I would give you this piece of information. So, 2 conversion factors. Okay, so got 2 fractions. One of them is going to have quarts on the bottom. The other one's going to have quarts on top. If it's got quarts on top, it's got to have liters on the bottom. If it's got quarts on the bottom, it's got to have liters on top. You will find this year that I do the units first all the time. Now I just have to copy numbers. The number next to liter is 1.00. The number next to quart is 1.096. And there are 2 conversion factors between quarts and liters. Both of those are equal to 1 because the thing on top and the thing in the bottom are the same size. So conversion factors are bizarre ways of writing the number 1. So I need you to be able to write these conversion factors. So where I need you to go is I need you to go to Canvas and go down the module, and you will see that right after the bell work, there's one that says making conversion factors. I need you to work on the one that says making conversion factors. So it says making conversion factors. I'll give you a few minutes. All it's going to ask you to do is make conversion factors. Actually, give me a second here. Actually, we got to be able to write fractions if we're going to do make conversion factors, right? So, where'd it go? That means we are going to need to learn how to use Canvas to make fractions. Okay? So, using Canvas for fractions. Okay? First, you got that little radical sign on your toolbar. Okay? And right here it says sub, that's subscript. Here it says super, that's superscript. The one we need is right here, and it says frac for fraction. And it lets me write a fraction. 1 inch is 12 feet. Nope, that's wrong. 1 foot is 12 inches. Then when you scroll down, it draws you a nice, lovely little fraction. We want vertical fractions. Now, if you want to edit that fraction, select it. It'll be a box, and then click the Insert Math Equation, and it'll open up and you can edit it. Oops, I got that upside down. So let me take the 12 inches off the top and put it on the bottom, and take the 1 foot and put it up top. So I'm going to ask you to show your work, and showing your work will include writing these fractions. So you're either going to have to do it on Canvas, which is okay, or you're going to have to no, people say it's not there, but it's there. Oh, you know what it is? It's not published. That's what happened. I was about to put it there. So you can either type in everything in Canvas, or you can do it on paper and write them as vertical fractions. And there, now it should be visible. You write them as fractions. If you do it on paper, write them as vertical fractions, and take a picture and share it with me, or send it up. Okay, it should be there now. I just published it. Give you about 5 minutes to write 4 conversion factors. 2 on the first one, 2 on the second one. Practice using the canvas. So hit that little button. Right there. One that looks like a radical. Use that insert. What's the last thing you heard? Can somebody put that in the chat so I can get you? It stopped at when we did the assignment. Okay, so I'll recreate all of that. All right. Okay. Dimensional analysis, also called the factor label method. Okay. Dimension means unit. And when we analyze something, we solve it by tearing it apart into pieces. So we are going to solve problems by tearing it apart into units. That the units will tell us how to solve the problem. Fact is, if you watch me do these problems, I always put the units first. So let the units first. Not screen sharing. Oh, it says I'm screen sharing. Oh. Sorry. Well, you had these already. So it's the factor label method, using units to solve the problems. Okay. Come on, computer, let me use. Ooh. I can't get to my screen now. So I can either, now you've taken over my screen. I can't get you out of the way. Ah. Okay. So a good motto to look like is, if you treat your units like algebra, and the units work out, chances are you did the math right. If the units don't work out, you definitely did the math wrong. Yeah. So let the units tell you how to do the problem. So tonight's homework has you doing it with metric units. So you need to know those equivalent statements. I listed them for you before. They weren't anything new. A whole bunch of things were equal to 1 meter. 10 decimeters, 100 centimeters, 1,000 millimeters, million micrometers, billion nanometers. Those are what I all learned. Those are all equal to 1 meter, and 1 kilometer is 1,000 meters. See how kilo is the only one that's different than all the other ones. Kilo has the 1 next to not meter. All the other ones have 1 next to meter. Okay. So we're going to use conversion factors that you wrote to change the units. And what we're going to be able to change is, on the homework tonight, if it has a prefix, we're going to use a conversion factor to get rid of that prefix. Or if you have one that doesn't have a prefix, you can use a conversion factor to add that prefix. So if you start with meters, you can turn it to centimeters with a conversion factor. Now, I know you don't need to do that because you've got the chart. You can go from meters to centimeters, got the chart. But that means you can check your homework tonight and see if you got the same answer both ways. In fact, I want you to check your answers both ways to make sure that you're doing it right. So our goal is to, if they've got a prefix, we need to get rid of it with a conversion factor. If it doesn't have a prefix, we can add one on with a conversion factor. Does it make more sense with me talking than just the words on the screen? That's why I don't just put up notes on the screen and say, here, copy these. Okay? So, let me erase all my math. Okay, 25 milliliters is how many liters? First thing I do is write down what they give me. 25 milliliters. And I focus on the units. I'm going to use a conversion factor because all I want to do is convert. What unit do I want to get rid of? Well, that would be milliliters. Where would I have to put milliliters so it'll cancel out? Well, milliliters would have to go on the bottom. What can I turn milliliters into? Well, I've got a prefix. I can get rid of that prefix so I can go to liters. Which is bigger, a liter or a milliliter? Well, a liter's bigger, so it gets the 1. The big unit gets the small number. And how many milliliters in a liter? Well, mil gives me a hint from my Spanish that it's 1,000. So notice I have written a ratio of equivalent measurements. The number on top and the number on bottom are the same volume, just measured in 2 different units. So that is equal to 1. So I'm taking 25 milliliters and I'm multiplying it by 1. So I'm going to get something that's the same size. So on my calculator, if numbers are on top, I multiply. If they're on the bottom, I divide. So 25 divided by 1,000 equals 0.025 liters. Now we can check to see that we did this right. I start off with milliliters, that's here. I wanted to go to liters. That'd be 1, 2, 3 to the left. So 25. 25, move it 1, 2, 3 to the left, and I get 0.025. Same answer both places. So my answers should agree with each other. Okay. Now that only took one conversion factor because I started with the prefix and I wanted to get rid of it. Here, I start with 5.86 times 10 to the minus 6 millimeters, and I want nanometers. This is going to take me two conversion factors. First, to get rid of the millimeters and change it to the base unit, then the base unit to nanometers. So I start off with 5.8 times 10 to the negative 6 millimeters. I copy what they gave me. I set up my conversion factor. I want to get rid of millimeters, so they have to go on the bottom. So this goes here. What can I turn millimeters into? I can turn millimeters into the base unit. That millimeters to meters, which is bigger, the meter's bigger, so it gets the 1. Millimeters is the, and the millimeter gets the 1,000, just like the one above it. Notice how these two conversion factors look the same. So I got rid of millimeters and gave me meters. Now, I want to get rid of meters. That's what I've got left. Where would meters have to go? It'd have to go on the bottom. What can I turn meters into? Meters I can turn into nanometers. Which is bigger? The meter's bigger, so it gets the small number, the 1. The nanometer gets the billion, 10 to the 9th. That way meters cancel out, and the only unit I'm left with is nanometers, which is what they asked me for. So now I got to push those buttons on my calculator. 5.8 e negative 6 divided by 1,000 e. Oops, nope, no e on there. Divided by 1,000. And then I got to put that 10 to the 9th in there, so the easiest way to do it is to get it in there as 1 times 10 to the 9th. So 1 times 10 to the 9th is the same size as 10 to the 9th. So I'm going to say times 1 E9. And if you push button successfully, you should get 5.8. And that's nanometers, because that's the only unit I have left. Okay, so that's how we do those problems. Okay. So, if you go to your Canvas module, sorry about this, it's just won't let me pick anything. There's a metric practice. And so it looks like this. I don't think you get to see the table quite as well. It's there, but you don't get to see it as formatting. But so it's got the diagram here, and number one asks you to take 46 centimeters and turn them into meters. So I've set up the conversion factor for you. First I wrote the 46 centimeters, then I wrote the conversion factor. Now I can go and edit that conversion factor, and I wanted centimeters on the bottom because that's the unit I had, and centimeters I'll be able to turn into meters. Okay? And now I got to remember which is bigger, a meter or a centimeter. Well, the meter's bigger, so the meter gets the 1. And how many cents in a dollar? That would be 100. So, oops, I have no idea why I just did that. Oh, well, we'll start over again. Fraction. 1 meter. And then I insert that. That says I need to take the 46 and divide it by 100, which is 0.46. And that is meters. Notice I type in the unit too. And then I can go back up here. I try to go back up here if it doesn't. And I can go back up here and said, okay, I started off at centimeters. I wanted to go to meters. I should move it 1, 2 to the left. 1, 2 to the left is, it should be a 6. I have no idea where the 9 came from. So my two answers should agree with each other every time. So in the second one's got deciliters to centiliters. That's 2 prefixes. That means it's going to take 2 steps. So I start off with the 499 deciliters. I write that down. And then I take my equation editor. And it was decimeters. Decimeters I can turn into meters. Which is bigger? Well, the meter's bigger. And there are 10 decimeters in a meter. So that's my first conversion factor. Oh, it's liters, sorry. I couldn't see the question while I was doing it. Liters. See, isn't that the beauty of the metric system? If I want to do that with ounces and pounds versus inches and feet, it would not have been as easy. So that takes care of the deciliters. Now I need to get rid of liters and turn it into what they asked me for, centiliters. So I had to get rid of liters. And I want centiliters. Oh, centiliters. And there is, the liter is bigger. So it's the 1. And how many cents in a dollar? Why, that would be 100. That over. And insert that. And now I just have to push buttons on my calculator. 499 divided by 10 times 100 equals 4,990 centiliters. And I was going from deciliters to centiliters, so on my chart that is moving it 1 to the right. So if I take 499 and move it 1 to the right, I will get 4,990 centiliters. Make sense? It's better with my voice than without my voice? Never thought you'd be glad to hear a teacher. Okay. So that's what I want you to do. There's some more of those to practice on the bottom. Practice making those. We're going to use this same technique to get to some really complicated problems. This is a really powerful technique using simple algebra. What do you want to get rid of? What can you turn it into? Where's it? Okay. So you got some time now to work on those other ones on the bottom. Thinking about going back and checking your density and percent error homeworks and see that you didn't make any silly mistakes. And quiz next time I see you on Thursday over all the way up through the metric system. So I'll expect you to know the metric system, but you won't have to do conversions, density, or percent error on the quiz on Thursday. It's going okay, making sense. So your answers now, if you don't feel like typing all that stuff in Canvas, you can take a picture and do it on a piece of paper and take a picture and upload it. I always give you that option. I prefer it on paper when I'm doing it. Typing on computer's no fun, especially when your microphone dies and you don't know. I should probably turn off the battery in between classes. Although there was no in between class. So the beauty of this is you get to check your own homework.